All right, trigonometry, not trigonometry, geometry. We are going to continue talking about trigonometry today. We looked at how to solve for missing sides of right triangles using trigonometry last week. So we know how to solve for this side, for example. So we essentially limited it down to a couple steps. So the first step we had to do was we had to label the sides of our triangle to help us figure out which ratio we need to use. So in this case, I know x up here. This is my hypotenuse of my triangle. 22 down here, based off of my angle, if I'm going off of this 36 degrees down here, this would be my adjacent side. So I know I have information for my adjacent side, my hypotenuse, and then this side, this blank side over here that I have nothing about is my opposite side. So thinking through, we had the mnemonic device SOHCAHTOA that we talked about. SOHCAHTOA could help us determine which of these ratios we need to use. Well, because we have information for adjacent and we're looking for the hypotenuse, we need to make sure we're using those two letters. So adjacent and hypotenuse shows up in cosine, so we know we're going to do the cosine of 36 degrees. So we have the cosine of 36 degrees, and cosine is equal to adjacent divided by a hypotenuse. So that's going to be 22 divided by x, my two distances for those. From there, once we got our ratio set up, we need to figure out, okay, what is the cosine of 36 degrees? And this is where you need to use the calculator, because unless you have this memorized, which I don't, we have to use that calculator to figure out. So you plug in cosine of 36 degrees, make sure your calculator is in degrees and not radians, and we should get 0.809 over 1 equals 22 over x. So we can always take whatever that ratio is, put it over 1, and then from here it's just cross multiplying. Cross multiply, cross multiply. Let me move this guy way over here. 22 times 1 is just 22. 0.809 times x is 0.809x. And then from there, it's just divide. So cross multiply and divide. So we're just dividing 22 by 0.809. Once again, try to round to 3 decimal places. Makes your answer more accurate that way. And so we get x equaling 27.19. Now, one way to check to make sure this answer is right, if we look, okay, so this adjacent side down here is 22 feet or 22 units. This hypotenuse we said was 27.19 units. Well, we know the hypotenuse needs to be the longest side. So if 27 was shorter, if we got an answer that was shorter than 22, then we know we would be wrong because our hypotenuse wouldn't be wrong. Our hypotenuse wouldn't be as long. So we know 27.19 should be close. It should be right. Assuming we have the correct ratio down, 22.09 should be correct. So we know how to do that. We know how to solve for missing sides. That's what we talked about last week. From here, though, what happens if I'm trying to find a missing angle? So let's say I have this triangle here. 35 is one side, 5 is another. I'm trying to find this missing angle here. Well, we're a little stumped there because looking based off my angle, I can assume, okay, this side's my opposite side. This side's my adjacent side. Once again, based off of my missing angle. So opposite and adjacent, thinking through SOHCAHTOA, opposite and adjacent show up in tangent. So I know the tangent of this missing angle here. This is the Greek letter theta. It's like a circle with a line through it. That's theta. This is the Greek letter that we often use to represent a missing angle. So anytime you have a missing angle, typically you're going to see this letter written. Otherwise, it might be a different variable. It's just a variable, though. So don't let this Greek letter confuse you. It's just a variable. So we're trying to figure out what is this missing angle here. What is theta? Well, we know it's the tangent of that angle would have to equal 3.5 over 5. Well, if we divide 3.5 over 5, this gives us 0.7. So we know the tangent of this angle pretty much has to equal 0.7. Well, maybe, if you're lucky, you might be able to remember from last week's video that if we did 3.5 over 5 and got 0.7, and we remember that the angle that we were working with was 35 degrees. But you would only know that if you remember that from last week's video, if you have a good memory. If you don't, we're kind of stuck, right? We would pretty much have to look up which angle has a tangent of 0.7. So we could come up with like a chart like this, and we could look at, okay, we have all these different angles, and we have all of these different degrees, and all of our different sine, tangent, cosine. So I know, like, if I took the tangent of 50 degrees, I would have 1.192. If I took the tangent of 55, I'd have 1.428. If I took the sine of 55, I'd have 0.89 or 0.819. So if I know my ratio, I can use this table, and that could work. So let's try a few of these. So using the ratios that we just talked about, using that table, we'll hop back and forth between it. Let's try to solve some of these. So let's see. Okay, based off, if I'm trying to solve this angle, I know 6.71 is my adjacent side. 8 is my opposite side. So this is going to be using tangent. So I know tangent of my missing angle theta would have to equal my opposite over adjacent, which is 8 over 6.71. Well, if I divide 8 divided by 6.71, that gives me 1.192. So I need to go back to my table, and I need to see which of these have a tangent of 1.192. So 1.192 tangent is right there. So we know that's going to be 50 degrees. So my angle would have to be 50 degrees. Not too bad. Let's look at another one. This one over here. So this angle, based off this angle, this side over here. So this has to be my hypotenuse because it's my longest side, opposite of my 90 degrees. So that means this side over here, opposite. It's a little weirdly shaped. And then my adjacent side. So once again, I have information for opposite and adjacent. So I'm going to use tangent again, because we know tangent is opposite over adjacent, equals 42.89 divided by 20, opposite over adjacent. 42.89 divided by 20, well, if I put that in the calculator, that gives me 2.145. Okay, so back to my thing. I'm using tangent. I got my ratio to be 2.145. So looking at our tangent, 2.142, that's pretty much the same. That's only off by 0.003 degrees, so that's pretty much the same. So that is 65 degrees. So we know theta in this case would have to be 65 degrees. All right, not too hard, not too hard. And we can get the same idea for this next one. Okay, so I have my angles down here at the bottom. This would have to be my opposite based off my angle, and this would have to be my hypotenuse. So opposite and hypotenuse we know shows up in sine. So sine of my missing angle theta equals 10 over 10.64. Well, what is 10 divided by 10.64? 10 divided by 10.64 is 0.940. Looking that up. So it's sine. So we know looking under our sine of 0.940 shows up right here, which is 70 degrees. So theta equals 70 degrees. Pretty easy, pretty simple. And we could do the same thing with the cosine, and we could get that one as well. Now, that's fun and all, but having to flip back and forth between all of those different, like having that table and then getting my answer, that's a lot of work. Also, what about, these are only going up by 5s. So this is only 50, 55, 60, 65, 70. What about 52 degrees or 63 degrees or 71 degrees? Like, this doesn't even have everything on it. So that table would be massive. So he needs to be an easier way. So luckily, we have things called inverse trigonometric ratios. So there is an easier way that allows us not to have to memorize things and not have to use a table. That's all built into our calculator. So these are our inverse trigonometric ratios. Now, once again, whenever we talk about inverse in math class, whenever we're talking about inverses, we mean the opposite or the backwards method, the method that cancels out the original method. So this is the backwards method of our trigonometric ratios. So we have an inverse sine, we have an inverse cosine, and we have an inverse tangent. They are represented by the inverse as this little -1. Sometimes maybe on like your ACT or your SAT, you might see it written as arc sine or arc cosine. Sorry, my phone is ringing. Let me pause this really quick. All right, sorry about that. Let me pull that back up. All right, so we have inverse ratios. So these inverses, once again, are the backwards or opposite method. So for example, inverse sine is the inverse ratio we use for sine. Inverse cosine, inverse tangent, and they're always represented by that -1. You also might see it as arc sine, arc cosine, or arc tangent on like a SAT or a state test or something like that. It's not as common to be written this way, but if you do see that, that's what it represents. It's the same thing as inverse. So what we do when we're trying to solve this is we know it's typically sine of my angle equals opposite over hypotenuse. Well, what we're doing essentially is you're just changing where that opposite over hypotenuse in that angle is. So inverse of my opposite over hypotenuse equals my angle measure. Inverse cosine of my adjacent over my hypotenuse equals my angle measure. Inverse tangent. So all you're doing is you're taking those numbers of those opposite sides and those adjacent sides and hypotenuse, and you're just putting the ratio in the parentheses compared to putting your angle in the parentheses. And with this one, you put it in the parentheses and it spits out your answer. It just spits out angle measure. You don't have to do any cross multiplying or anything like that. It's super simple. So let's look at an example of this. All right, so I have this angle here. So based off of my missing angle down here, this side would have to be my hypotenuse because it's my longest side across from my 90 degrees. This side has to be my adjacent because it's next to my angle. So I'm using the cosine because this is adjacent over hypotenuse. So we're doing inverse cosine. So cosine to the -1 is that inverse cosine. And it's adjacent over hypotenuse. So I'm going to put 10 over 13.05 in my parentheses. So in my calculator, I'm going to type cosine to the -1, parentheses 10 over 13.05. There's also an inverse cosine function. It should be right under the cosine function button on Desmos. If you're using Desmos and you're hitting the buttons, inverse cosine is right under that. Otherwise, you can do cosine to the -1. All you have to do is type that in. It spits out your answer. So in this case, it spits out the answer 39.979. That's really terrible writing. I'm so sorry for that. 39.979 degrees, which is pretty much saying it's 40 degrees. It's very close to 40 degrees. So 40 degrees or 3.9979 is our answer. Let's look at this one over here. Same idea. Okay, first I want to identify my side. So look, I'm using opposite based off my angle up here, and then adjacent based off my angle. Opposite and adjacent we know is tangent. So I'm doing inverse tangent of opposite over adjacent. So 20 over 12.5. 20 divided by 12.5. We type that whole thing into our calculator, put in those parentheses, and that gives us 57.995, which is pretty much saying 58 degrees. And that's our solution. Now, once again, I recommend rounding to the 3 decimal places just to know you're accurate and just know to correct. But when you have like 9.something99 like this, it's pretty much saying it's that number. All right, last question. So the diagram below shows a ramp connecting the ground to a loading platform of 4.5 feet above the ground. The ramp measures 11.75 feet from the ground to the top of the loading platform. Determine the state to the nearest degree. So we're going to the nearest degree. We don't have to worry about it in decimal places. The angle of elevation formed by the ramp and the ground. Okay, so I have this picture here. So I'm looking for to the nearest degree, the angle of elevation formed by the ramp and the ground. So we're looking, the ramp and the ground are touching over here. So this is the angle of elevation that we're looking for. So what is this angle, that theta? Well, based off our angle, we have an opposite side of 4.5. We have a hypotenuse of 11.75. So we know this is going to be sine using opposite and hypotenuse. So inverse sine, because we're looking for the angle of our opposite side divided by our hypotenuse. All we have to do is type that in the calculator. Inverse sine, 4.5 divided by 11.75 gives us 22.518. Now, once again, we're asked to round to the nearest degree. So we are cutting off our decimals. But because we have 0.5, we want to round up. So this is going to be rounded 3 degrees is our solution to the nearest degree. And that would be our solution for our angle of elevation. And that's how we use inverse trig ratios. They're super easy. All you have to do is really just use that calculator. Make sure you're figuring out what trig ratio do you need to use, sine, cosine, tangent, and then type in sine of inverse sine of whatever, inverse cosine of whatever. Make sure you're putting those ratios in the fraction or in that fraction form in those parentheses, and then it's just going to spit out your answer, and that's pretty much all the math you need to do. So once you get your sides labeled and figure out which ratio, the calculator pretty much does the rest. So that's where we're going to call it for today. Let me know if you have any questions. We'll have some practice over this. Have a great rest of your day.